Let's look at number 2. The sum from n equal 1 to infinity of negative 1 to the n plus 1 times x to the n over the square root of n. I'm going to figure out where I'm centered. Here's my x. It's by itself. I set it equal to 0. I get x equals 0, so I know that I am centered at 0. Now let's do the ratio test to determine the interval of convergence. So we're looking at the limit as n goes to infinity of the absolute value. Since I'm taking the absolute value, I don't worry about this alternating piece. This guy right here, when you do the absolute value, it just goes away because that alternates between negative 1 and positive 1, and that just is not necessary when we're doing the absolute value because that number is just going to be 1, and anything times 1 is itself. So we don't worry about that, and we just put in x to the n plus 1 over the square root of n plus 1. And then we're dividing it by a sub n or multiplying by the reciprocal, and if we do the reciprocal there, it's just going to be the square root of n over x to the n. Now let's expand and try to figure out what this limit is. We're looking at the limit as n goes to infinity, and this guy here becomes x to the n times x to the first. I'm going to put it over my x to the n, and then I have the square root of n over the square root of n plus 1. Well, my x to the n's will cancel, and then here I notice I have the square root of n and the square root of n plus 1. So you can really think of that as the square root of the whole entire thing. So that would be x times the square root of n over n plus 1. Well, I can split this up into two separate limits because the limit of a product is the product of its limits. So you can split this up as the limit as n goes to infinity of the absolute value of x times the limit as n goes to infinity of the absolute value of the square root of n over n plus 1. Well, just like we did in our ratio test video, since this is the limit of a composite function, we can rewrite this guy here as the square root of the limit as n goes to infinity of the absolute value of n over n plus 1, so that we can realize that, hey, this is just a rational function, and that's really just n over n, which is just reducing to 1, so it's the limit as n goes to infinity of 1. Over here, this is the limit of a constant, and the limit of a constant is equal to the constant, so the limit as n goes to infinity of the absolute value of x is just the absolute value of x. So if I keep going here, this is going to be the absolute value of x times, and we just said that this guy here was going to be the limit as n goes to infinity of 1, and we know that that guy is going to be 1, so the square root of 1 is 1, and we still end up with just 1 times the absolute value of x, which is just the absolute value of x. So we did the ratio test, and we ended up with the absolute value of x. What does that mean? Well, that puts us here at number 3. We're left with the absolute value of x minus c. So what we need to do is we have to then solve this inequality. The absolute value of x minus c is less than 1. So you take what's left over, this right here, and you're going to set it less than 1 and solve that inequality. I'm going to move us over here to the right. So I have the absolute value of x less than 1. Well, this is an absolute value less than inequality, and that turns into a compounded inequality. We get trapped between the negative and the positive of 1. Well, this is already solved for x because x is all by itself in the middle. So if you're thinking about this as a number line, since you're centered at 0, you get to move all the way to negative 1 and to positive 1. So if you think about it, r, that radius of convergence, is going to equal 1 because you get to move 1 unit away from your center. Now, we have to check the endpoints because anytime we end up with number 3, we have to check the endpoints to see if they need to be included or not included. Included will happen if the series converges at that endpoint, and excluded will happen if the series diverges at that endpoint. So let's go ahead and check x equal negative 1 and x equal 1 and see what happens. When we're checking them, what we do is we plug in those numbers into the given. So we're going to start by checking x equal negative 1. If I'm checking x equal negative 1, I end up with the sum from n equal 1 to infinity of negative 1 to the n plus 1. And then instead of x, I say negative 1 to the n because, again, instead of x, I'm plugging in a negative 1, and then it's still all over the square root of n. Well, now I need to clean this up because I need to determine what's happening. Well, negative 1 to the n plus 1 times negative 1 to the n, since the bases are the same, they're both a base of negative 1, and we're multiplying, we add the exponents. So that becomes n plus 1 plus n, or negative 1 to the 2n plus 1. So we have negative 1 to the 2n plus 1 all over the square root of n. Well, 2n plus 1 is the formula for an odd number, so this always gives us an odd number. If I take negative 1 and I raise it to an odd number, so negative 1 to the first is negative 1, negative 1 cubed, negative 1, negative 1 to the fifth, negative 1, etc. So this no longer alternates, this is always negative 1, so you're really just looking at the series of negative 1 over the square root of n, and negative 1 we know is a constant multiplier. We can factor it out of our series, and we're looking at negative 1 times the sum from n equal 1 to infinity of 1 over the square root of n. So now I have to determine, does this series converge or diverge? Well, what is that? Well, it's a known series. It's a p series. We have a p series. P here is equal to 1/2 because it's the square root, and that's a number that's less than 1, therefore we know that this guy is going to diverge. So our series diverges, so we know that when we're doing the interval of convergence, we will not include negative 1 in our interval of convergence, it'll get a parentheses. So now let's check the other one, let's check x equal 1. Well, again, all we're doing is plugging it back into here. So we're looking at the sum from n equal 1 to infinity of negative 1 to the n plus 1. And instead of writing x, I'm going to write 1 to the n all over the square root of n. Well, 1 to the n is multiplying something by 1, and multiplying something by 1 is just itself because it's the multiplicative identity, so we don't need to worry about that guy, and we're just looking at the sum from n equal 1 to infinity of negative 1 to the n plus 1 over the square root of n. Well, what is this? Well, this is an alternating series. Since it's an alternating series and all I want to know is, does this thing converge or diverge? What I do is jump to that alternating series test. Now the alternating series test said first take the absolute value of a sub n. We take this absolute value, we get 1 over the square root of n. And then we have to show that the limit as n goes to infinity of a sub n is equal to 0. What is the limit as n goes to infinity of this? Well, the limit as n goes to infinity of 1 over the square root of n is just going to be 1 over infinity, and that's 0. Perfect. That's the first part of the alternating series test that's met. Second thing is that a sub n plus 1 had to be less than or equal to a sub n. So is 1 over the square root of n plus 1 less than or equal to 1 over the square root of n? Remember, if you weren't sure, you could always cross multiply. So is the square root of n less than or equal to the square root of n plus 1? Yes, it is. Therefore, by that alternating series test, we converge. Since we converge, when we're finding that interval of convergence, remember the numbers that we had were negative 1 and 1. At negative 1 we diverge, so that number gets a parentheses. At 1 we converge, so that number gets a bracket. So the interval of convergence are the numbers between negative 1 and positive 1, not including negative 1 and including positive 1. What that means is that for this particular series, what you can do is plug in the numbers between negative 1 and positive 1, not including negative 1, and that series is going to converge. Okay, let's look at the next one, example 6. The sum from n equal 1 to infinity of n factorial times x minus 4 to the n. Again, where is this thing centered? Well, if I set x minus 4 equal to 0, I solve for x. I know that I am going to be centered at 4. Now let's go ahead and find that interval of convergence. How do I do that? I use the ratio test. So we do the limit as n goes to infinity of the absolute value of a sub n plus 1. So here I write n plus 1 factorial, and then x minus 4 raised to the n plus 1 divided by a sub n. And typically we multiply by the reciprocal, but since I don't have a fraction right now, I'm just going to go ahead and divide it by that a sub n, or it's given, n factorial times x minus 4 to the n. Expand this, the limit as n goes to infinity n plus 1 factorial is the bigger one, so that becomes n plus 1 times n factorial. And that's all over n factorial. And then over here, if I expand this, this is x minus 4 to the n times your x minus 4 to the first, all over x minus 4 to the n. What cancels? The n factorials cancel, the x minus 4 to the n's cancel. What are you left with? The limit as n goes to infinity of the absolute value of just n plus 1 times x minus 4. Well, what is the limit as n goes to infinity of the absolute value of n plus 1 times x minus 4? Well, remember this guy here is just a constant multiplier, multiplies along. So what's the limit as n goes to infinity of n plus 1? Well, that's going to be infinity times that absolute value of x minus 4, but infinity times x minus 4 is just going to equal infinity. Since we ended up with infinity, what will our answer be? If we look at our three options, if you end up with infinity, what that meant is that your series diverges and your interval of convergence is just your center. For us, for number 6, since we knew that this meant that the series diverges, our interval of convergence is only going to be at the center, and our center is 4, so our interval of convergence is going to be 4. Now you'll see it this way, and you'll also see it as x equal 4. Either answer is correct. Let's look at the last one of these before we get to the derivatives and the integrals. Number 7, which is the sum from n equal 1 to infinity of 3x minus 2 to the n all over n. The first thing we do is figure out where we're centered. So that would be a 3x minus 2 equals 0. We solve this and we end up with x is equal to 2/3, so we know that we're centered at 2/3. Now we need to find that interval of convergence. How do you do that? You use the ratio test. So the limit as n goes to infinity of the absolute value of a sub n plus 1, so 3x minus 2 raised to the n plus 1 all over n plus 1 times the reciprocal of a sub n, which is just n over 3x minus 2 raised to the nth power. Expand where you can. The limit as n goes to infinity of the absolute value, this guy up here is 3x minus 2 to the n times 3x minus 2 to the first, and I'm going to put it all over its like term of 3x minus 2 to the n, and then times n over n plus 1. Now your 3x minus 2 to the n's will cancel, and you're just left with the limit as n goes to infinity of the absolute value of 3x minus 2 times n over n plus 1. Now this guy here is just a constant multiplier, and then over here you have the limit as n goes to infinity of n over n plus 1. Well, this is just a rational function. We know that we can just look at those leading terms. N over n reduces to 1, so you can think of this as the limit as n goes to infinity of the absolute value of 3x minus 2 times 1, which is just going to be the absolute value of 3x minus 2. Because remember, this is a constant multiplier, and the limit of a constant is the constant. Now, which option were we? Well, if you go back and look, we're option number 3, because the first one says you're greater than 1 or infinity, and your interval of convergence is just your center. The second one was where you end up with a number that's less than 1, and your interval of convergence is negative infinity to positive infinity. And we ended up with number 3, which meant that we needed to set that absolute value less than 1 and solve it to find our interval of convergence, because when the ratio test leaves you with the absolute value of x minus c, set it less than 1 to find your interval of convergence. Let's go ahead and do option number 3 for this guy. If we take this here and set it less than 1, this is an absolute value less than inequality, so it gets trapped between the positive and the negative of this number. We say negative 1 less than 3x minus 2 less than 1. To solve, we first add 2 to all three sides, and we get 1 less than 3x, which is less than 3. Finally, divide everything by 3, and you get 1/3 less than x, which is less than 1. We know from earlier that we were centered at 2/3. Since we're centered at 2/3 and we're going to 1/3 and to 1, we can tell here that our radius of convergence, how far we're moving away from our center, is 1/3. The question is, do I include the number 1/3? And do I include the number 1 with the interval of convergence? I'm not sure. How do we find out? We have to check the endpoints. So let's go ahead and check those endpoints. Since we can't see the series, I'm going to rewrite it. Recall number 7 is just the sum from n equal 1 to infinity of 3x minus 2 to the n over n. Let's start by checking x equal 1/3. That means that I'm going to plug in a 1/3 in place of that x. If I plug in a 1/3 in place of that x, that's 3 times a third. Well, 3 times a third is 1, and then 1 minus 2 is -1. So that becomes a -1 to the n. Again, all I've done is, instead of writing this x, I've written in a 1/3 and just did the math in my head. 3 times a third is 1. 1 minus 2 is -1, so that's a -1 to the n. Well, now, what are we looking at? Well, the sum from n equal 1 to infinity of -1 to the n over n is an alternating series. Since it's an alternating series, I can use the alternating series test. Find the absolute value of a sub n, and you're looking at 1 over n. Then, what's the limit as n goes to infinity of 1 over n? Well, that's 0. The first part of the alternating series test has been met. The second part is a sub n plus 1 less than or equal to a sub n. Well, is 1 over n plus 1 less than or equal to 1 over n? Yes, if you're unsure, remember you can always cross multiply. Therefore, by that alternating series test, your series converges. What does that mean for us? That means that 1/3 gets included in our interval of convergence. Now let's check the other one. Let's check 1. So we're going to check x equal 1. That becomes the sum from n equal 1 to infinity. Remember, instead of this x right here, we're going to be writing a 1. So 3 times 1 is 3, minus 2 is 1. You're looking at 1 to the n over n. Well, 1 to the n is just 1, and if we're multiplying everything by 1, then we don't really need a 1 to the n. That's just really just 1. So we could rewrite this series as the sum from n equal 1 to infinity of a 1 over n. And if it's 1 over n, what is it? It's a known series. It's a p series. P is equal to 1, therefore we know that we are going to diverge. Now we have all the information that's necessary to find our interval of convergence. Because the interval of convergence, remember, were the two numbers 1/3 and 1. At 1/3 we converge, that gets a bracket. At 1 we diverge, that gets a parentheses.